I'd like to do a little review of counting sig figs, going over the rules for counting sig figs. Non-zero numbers are always significant. That would be all your non-zeros 1 through 9. So 1, 2, 3, 4, all the way up to 9. We use these digits to create other numbers, like we could combine 1, 3, and 5 to make 135. But individually, we count them as significant digits. Lead zeros are never significant. Lead zeros would be those zeros to the left of a number. So something like 0.0056. These guys would be considered lead zeros. Captive zeros, those would be zeros between non-zeros. So if I had something like 104, this zero is a captive zero. Captive. It's a captive zero. And you can have more than one captive zero in there. These guys are always significant. Lead zeros never significant. Non-zeros always significant. Trailing zeros are only significant if there's a decimal point present in the number. Trailing zeros would be zeros all the way at the end of a number, the right side of a number. Something like 2,500. These guys right here would be considered trailing. Those guys are trailing zeros. So those guys are only significant if there's a decimal point present. Let's go ahead and take a look at a few examples and count up our sig figs. Something like 135.7. I've got a non-zero, a non-zero, a non-zero, a non-zero. That would give me 4 sig figs. These guys are all non-zeros. Let's take a look at something like 0.0431. I've got 2 lead zeros here, so these guys are lead zeros. And they are never significant, so I wouldn't count those. And then I've got 3 non-zeros, so I'd have 3 sig figs. Again, just the non-zeros. Let's take a look at something like 2.07. This guy right here is a captive zero. He is always significant. So I would have the 2 non-zeros and the 1 captive zero, so I would have a grand total of 3 sig figs. One captive zero, and 2 non-zeros. Take a look at something like, what is this? 4,100,003. This would have 1, 2, 3, 4, 5, 6, 7 significant figures. These guys are all captive. And they're always significant. So what I would have is I'd have 3 non-zeros and 4 captive zeros, giving me a grand total of 7 sig figs. 105.006. This guy's a captive. These two are captives. What I would have is a grand total of 1, 2, 3, 4, 5, 6 sig figs. I would have 3 non-zeros and 3 captive zeros. $200, no decimal point. That would give me a grand total of exactly 1 sig fig. These guys are trailing zeros with no decimal point. So because there's no decimal point there, those zeros are not significant. I have 1 decimal point. 4,100 with a decimal point after it. That would give me a grand total of 4 sig figs. 2 non-zeros and 2 trailing. With a decimal point. So that decimal point makes those significant, those zeros, those trailing zeros. Last example here, I've got 0.00410030. I've got 3 lead zeros. Which are never, so I'm not going to count those. I've got 1, 2, 3 non-zeros. I've got 2 captive zeros. Those guys are always. And then I've got 1 trailing zero. With a decimal point. There's my trailing. Gives me a grand total of 6 sig figs. All you have to do is apply the rules and count them up, and you're all set.